Hey boys and girls, so today I am home trying to make a video the best way I know how. So hopefully you guys can see that okay, and I'll try to write really big so you can see everything that we're talking about. So this week we're going to start talking about dividing fractions, which thankfully you guys have had a lot of practice with that because we've been multiplying fractions and we've learned from a very early age that multiplying and dividing go hand in hand. They're inverse operations. So like when we say 2 times 3 is 6, we then know 6 divided by 3 would give us 2. So 2 times 3 is 6. 6 divided by 3 equals 2. Those are inverse operations, and we can use what we know about multiplying to help us divide. So that's what we're going to talk about today. And we're also going to repeat something that we've said so many times this year. A fraction is a division problem. A fraction is a division problem. When we are making fractions, we're making a division problem. We've probably said that every single day, and I have y'all do that so that hopefully it will help this make more sense to you. Okay, so let's start looking at this page, and I've got my other books down here, so I'm trying to figure out the best way to do this. All right, so it says in elementary school, so we're on page 239, and we're in your 10 through 20 book now. So we should be finished with 1 through 9. Don't throw it away or anything, because I might be forgetting that we need to go back to it for a reason later. But for the next while, we're going to be in this 10 through 20 book. Okay, page 239. An elementary school receives 5 boxes of minerals for its earth science class. The 6 science teachers at the school share the boxes equally with their classes. What fraction of a box will each teacher receive? Okay, so the first thing I always say when we're dividing anything is what is being divided. What are we dividing here in this problem? We know that we're getting equal shares. We know that we are sharing the boxes equally. That's what the problem says. So that helps me know that we're dividing. So we need to think, what are we dividing? Are we dividing the 5 boxes, or are we dividing the 6 science teachers? That's why I've always said no naked numbers. It's easy to say 6 divided by 5 or 5 divided by 6, but we probably won't say 6 teachers divided in 5 parts. So when we look here, we know that our 5 boxes are being divided among the 6 teachers. So there's our division problem. 5, 6, or 5 divided by 6. Now if we write 5 divided by 6 like that, it's a little confusing because we think, oh gosh, 5 is smaller than 6. I'm not really sure what my answer is going to be. Yes, you do, because a fraction is a division problem. So if you get 5 boxes and 6 teachers share them, your 5 boxes are divided among your 6 teachers. So this is a very easy way to divide when you're using whole numbers. Just like we have any other time we've been dividing, except these are a lot smaller numbers than what we're doing. So each teacher is going to get 5/6 of a box. And if we were to draw that out, we know we have 5 boxes. 1 box, 2, 3, 4, 5. And there's 6 teachers. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay? So there's 6 teachers. So I get 1 of this piece of box, and 1 of this piece, and this, and this, and this. I get 1 from each thing because we split them all in 6 parts. So that's 1, 6, 2, 6, 3, 6, 4, 6, 5, 6. I get 5/6 of those minerals. Okay. Let's turn over to the back. I'm going to try to reuse my stuff here. Good. I was scared it would come through the paper, but it really didn't too bad. Okay. So on page 240, 5 students in the science club prepare 4 circuit boards for a small satellite called a CubeSat. If they share the work equally, that's very important. That's helping me know. How many circuit boards does each student prepare? So again, let's think. What is being divided here? We have 5 students and we have 4 circuit boards. The question says, how many circuit boards does each student prepare? So we're going to draw to represent the situation, but always, what's being divided here? Obviously, this is what's helpful when we're reading and we're careful. We are not dividing our 5 students. That's against the law. Okay? We're going to divide our 4 circuit boards. So if we're going to draw your 4 circuit boards however you want to. Mine are very beautiful and detailed like these right here. Okay? 5 students are preparing those and they're sharing that work. So it's not like one person's going to do these 2 and then one person will do that one person will do that one, and then the 5th person doesn't have to do anything. They are sharing the work equally. So if there's 5 of them, if you want to show a picture, then you're splitting this into 5 parts. 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. 1, 2, 3, 4, 5. Okay, so we're drawing to represent that. So B says, how does your drawing represent this situation? Well, I drew 4 boards and shared, or in divided, whichever you want to say, each board among 5 students. Right? Each one I split 5 ways. So C says, what does the expression 4 divided by 5 model? Look, that's what we wrote. 4 things divided into 5 parts. 4 divided by 5, what does that expression model? That just means 4 boards. Spelled it wrong. Boards divided among 5 students. Whoa. Okay. Write a division equation to model it. 4 divided by 5 equals 4/5. 4 divided by 5, a fraction is a division problem. This is why we've been saying this all year. What does your quotient represent? Remember, quotient is the answer to a division problem. What does your quotient represent? That represents the amount of work each student does. Remember, we had 4. They're sharing the work equally. So 4/5 is how much work each student is going to have to do. Okay, let's look at the next page. I've got to tear it out really fast. Okay. I am reusing this tape like a champ. Okay. All right. 2 scientists develop a new substance in a laboratory. They make a total of 5 milliliters. If the substance is shared equally, how many milliliters does each scientist get? So again, we are starting to first say, what's being divided? Remember, we have 2 scientists that are making a new substance, and they make 5 milliliters. The substance is being shared equally. The substance, the 5 milliliters. We're going to talk about those later in the year, but that's how you write milliliters. Is shared among what? Each scientist. How many do we have? 2. So 5 divided by 2. 5 divided by 2. So in this case, I have my visual model. Let me draw it here because I forgot to draw it down there. Got my 5 boxes, and I'm going to put them all in half. So I have my 5 things, and each scientist is going to get their own part. So 5 divided by 2, or there's 5 halves. Don't you have 5 halves right here? Yes. Each one is getting your 5 halves. So I'm one scientist. I get 1, 2, 3, 4, 5 of those halves, which is equivalent to 2 goes into 5 2 times with 1 left over. So I get 2 1/2. And if we were to draw a big line right there, we could look at it that way too. 2 whole things and a half, 2 whole things and a half. Depends on the way that you want to look at it. Probably we answered all these questions. How does your visual model represent the dividend, divisor, and quotient? Okay. So remember that the dividend is what, so here's your dividend. It's what's being divided. Divisor is what you're dividing by. And your quotient is your answer. What is the size of each group, and what does it mean for the situation? So we can say that each group is 5 halves, or 2 1/2. And all that means is each scientist gets 5 halves, or 2 1/2. What division expression models this situation? 5 divided by 2. Remember, an expression does not have an equal sign. Divide the expression you wrote in part B and compare it to your answer in part C, which is just 5 halves. It's saying actually divide it, which gives us 2 1/2. And they are equivalent. Just a different way to write them. All right, let's look down here at number 1, and then we'll stop. I know this video is getting long. 3 runners in a relay race share the 8-mile distance equally. How many miles does each runner travel? Be careful with this. The main mistake that I'll see here, because this is simple, is I'll have students write, oh, 3 divided by 8, 3 eighths. But what does 3 represent? 3 runners. Do we like to divide runners? No, we don't want to divide runners. Those are people. How many miles does each runner travel? 3 runners are sharing the miles. So we're dividing 8 by 3. 8 thirds. 3 goes into 8 2 times with 2 thirds left over. So each runner is going to run about 2 2/3 miles. Hopefully, if you did answer this one, you would say, wait a second, if they each run 3 eighths, 3 eighths, 6 eighths, 9 eighths, that's barely more than a mile. They're supposed to be running 8 miles. So hopefully you would see that that did not add up. Again, like we said all year, you've got to make sure that you're making sense of your problems. Make sure you ask if they make sense. This kind of problem is very similar to what you're going to see. It's very simple, but it's very easy to do it incorrectly. All right, so continue working there. Work on that homework. If you have any questions, let me know.